what is the reason behind the heat wave in the Indo-Pacific? Hello, friends. Jim here. Well, ocean warming. Ocean warming triggers Indo-Pacific heat waves, a new study indicates. An intense heat wave gripping South and Southeast Asia since late March comes as no surprise to leading meteorologists who've been warning of steadily rising temperatures in the Indian Ocean. Temperatures in the Philippines and Thailand have topped 50 degrees C this month, while Bangladesh has recorded almost 30 days of heat waves leading to deaths from heat stroke and school closures. Scientists say the heat waves are directly linked to climate change and ocean warming, which are likely to bring even more intense weather events such as cyclones. Let's pause there for a moment. Ocean warming. The oceans have absorbed over 93% of heat energy humans have inputted into the planetary system. Well, that's being returned. It's being returned as the heat diffuses to the atmosphere, but also a warming atmosphere can hold more moisture, and there's also an increased evaporation from the oceans. And then you get cyclones and other such storms. While the Indian Ocean has undergone basin-wide surface warming at a rate of 0.12 degrees C per decade between 1950 and 2020, models now show that greenhouse gas emissions will likely accelerate surface warming at a rate of 0.17 C to 0.38 C per decade between 2020 and 2100, says Roxy Matthew Cole, top scientist at the Indian Institute of Tropical Meteorology. So, all those folks who keep saying it's all due to reduction in aerosol, if the scientists are saying that, 0.17 to 0.38 C per decade, that certainly does not explain, or aerosol does not explain, a 5 to 7 C increase in sea surface temperature in the North Atlantic over the last couple of years. So, aerosol impacts the atmosphere, not the ocean. Okay? And again, we're talking, they're just talking about right at the surface, which is where any increased sun energy penetration is to be felt. Don't forget, sun energy attenuates rapidly. It's an exponential decay function. So by the time you get away from the first couple of meters, it's other processes that mix in the heat energy into the ocean. And we're finding out more and more that this is mesoscale eddies. But again, look at these rates here, right? Look at these rates per decade, right? That's an estimate. It's 0.12 up to 2020. Not 5 to 7 C in 1 to 2 years. It's ocean heat content, folks. That's what it is. A recent study led by Cole on future projections for the Indian Ocean, published in the Indian Ocean and its role in the global climate system, projects marine heat waves as increasing from 20 days per year, such as from 1970 to 2000, to as much as 250 days per year. Increasing from 20 days per year to as much as 250 days per year. In other words, 5/7 of the year. Holy moly. This, it says, would push the tropical Indian Ocean basin into a near permanent heat wave state by the end of the 21st century. Though the warming is basin-wide, the northwestern Indian Ocean, including the Arabian Sea, will see maximum warming, while the intensity will be reduced off the Sumatra and Java coasts in the southeast Indian Ocean, says Cole. Mid to high greenhouse gas emissions will likely see the Indian Ocean experience surface warming of between 1.4 C and 3 degrees C in 2100. Cole says projected shifts in surface temperatures hold implications for cyclones and other extreme weather events over the Indo-Pacific region. While the maximum basin average temperatures in the Indian Ocean during 1980 to 2020 remained below 28 C, the minimum temperatures by the end of the 21st century will be above 28 C. That's some very warm water. That is a lot of energy stored. A lot of latent, sensible heat there. Sea surface temperatures above 28 C are generally conducive for deep convection and the generation of cyclones. Convection of the atmosphere. Adding that heavy rainfall events and extremely severe cyclones, which were on the increase since the 1950s, are projected to increase further as ocean temperatures rise. And don't forget, there's a lag effect from what we're seeing here. So these things are locked in. Pipeline warming that I've discussed with you guys before. There could be rapid intensification of cyclones, meaning that a cyclone could intensify from a depression to a severe category in a few hours. Well, we're already seeing some examples of that, like in the Caribbean and in the Eastern Pacific. Other consequences of ocean warming include coral bleaching, seagrass destruction, and loss of kelp forests, seriously impacting the fisheries sector. Seagrass beds and kelp forests are important nurseries for juvenile organisms, fish included. You lose the seagrass, you lose the kelp, you're going to adversely impact recruitment, cohort, year class strengths. It's going to lead to massive declines in population numbers. The current heat wave has severely affected eastern India and countries in Southeast Asia such as Cambodia, Myanmar, the Philippines, Thailand, Vietnam, which have reported record temperatures reaching up to 48 C. In many of these countries, schools have had to be ordered closed amid reports of heat stroke deaths. Hate to see what the wet bulb temperature is. These areas tend to be humid. In the Philippines, as the heat index, which combines temperature and humidity, rose to more than 42 C. Well, there it is. Well, that's, 32 C above that is considered to be leading to hyperthermia, which can lead to severe health issues and death. If it's approaching 42 C, that's just horrible. So far this year, the highest recorded heat index in the Philippines reached 53 C on 28 April, which is off the record of 60 C on 14 August 2023. In Thailand, temperatures have also topped 50 C, causing at least 40 deaths from heat stroke, and also just doing crazy stuff to orchids and poultry farms. On 28 April, Bangladesh recorded 29 days of heat waves, surpassing the previous high of 23 heat wave days in 2019. Temperatures since decreased enough that schools have reopened. Jaya Narayanan Kudapurat, who is an associate professor at the Indian Institute of Technology in Kharagpur, attributes the warming to higher concentrations of CO2 as well as increase of water vapor in the atmosphere. Our study showed that atmospheric water vapor has been increasing in India and across the world, amplifying global temperature rise. Well, it's also the ocean heat content that we're seeing increased evaporation, leading to increased water vapor. And that ocean heat's diffusing to the atmosphere. Okay, you have to consider those factors in addition. There has been a continuous rise in atmospheric moisture, which amplifies warming and thus heat waves, said Kudapurov. This is evident in coastal states like Kerala, Odisha, West Bengal. Also neighboring Bangladesh and Myanmar, where temperatures reached 48.2 C. In addition, impact of El Nino and its departure, during which highly oceanic temperatures is expected, might have also impacted heat wave conditions. That is extremely likely. El Nino conditions were recognized during the summer to fall of 2023, and by the start of 2024, it had transitioned into a neutral state. It's probably still in a neutral state, maybe heading to a La Nina conditions. There are other interannual, decadal, and multi-decadal climate variabilities which can either enhance or dampen these changes in regional climate, but global warming and climate change would be the primary factors responsible for severe heat waves in the future, said Kudapurov. Okay. He's referring to the Indian Ocean Oscillation, as well as ENSO, as well. And probably the Interdecadal Pacific Oscillation. I've done deep dive videos on all the major oscillatory systems for the planet. So they've been out for several years, but you may want to go check those out. So we are seeing climate change right now. So this is what they're talking about, the western portion of the Indian Ocean towards the Arabian Sea. And then we're seeing the maximum. This is all being affected. All of this. And, again, you have meteorologists, atmospheric scientists not really taking fully into account the ocean. And I've shown you with my ocean heat content videos, what's happening in the Indian Ocean as well as the Pacific and the Atlantic and the Southern. So I think it's ocean heat content because of the stratifying ocean. The heat is diffusing to the atmosphere. There's an increased evaporation rates, adding to the moisture, adding to the heat, to the warming atmosphere that can hold more moisture, in addition to the increased CO2 trapping more heat. But there's a delay. The levels we measure, the effects that we experience now is from levels of about 10 years ago. And then you add in pipeline warming, which is already guaranteed warming. And it's not painting a very good picture. Imagine this happening across the Pacific, across the Atlantic, across the Southern Ocean. That 93% of heat energy that's been stored in the ocean, it's like a battery, it's like a capacitor. That's eventually going to do something. And the eventuality is happening now. It's being returned to us. And the impacts are not going to be pleasant one bit. Not only for humans, but for many species. Buckle up. It's going to be a wild ride. Thank you for your time.